Welcome to Chapter 5, Data Resource Management. Data resource management is a managerial activity that applies information technology and software tools to the task of managing an organization's data resources. Early attempts to manage data resources used a file processing approach in which data were organized and accessible only in specialized files of data records that were designed for processing by specific business application programs. This approach proved too cumbersome, costly, and inflexible to supply the information needed to manage modern business processes and organizations. Thus, the database management approach was developed to solve the problems of file processing systems. In this chapter, we're going to explain the value of implementing data resource management process and technologies in an organization. We'll outline the advantage of database management approach to managing the data resources of a business compared with the file processing approach, which was used traditionally early on in data processing life. And then we'll explain how database management software helps business professionals and supports the operations and management of businesses. We'll also provide examples to illustrate each of the following concepts: major types of databases, data warehouses and data mining, logical data elements, fundamental database structures, and database development. You will be impacted by database resource management systems in your career. It is imperative that you understand them and that you know how to leverage the data that is going to be in your business and accessible through these database management systems. There is such a wide variety and vast amount of data available to every business that this data must be structured and organized in some logical manner so they can be accessed, processed, retrieved, and managed easily. And further, that data represents a body of knowledge that can be used, translated, and trend analysis can be formed and analytics performed to help us make better decisions as business people. To understand the data, we must first identify how database management systems operate. The basic level or unit of measure within a database is a character, which is the most logical base data element that can be observed, a single alpha or numeric or symbol represented by 1 byte of data. A collection of characters is called a field, such as last name or salary, and represents an attribute of some entity general purpose application programs. A collection of fields is called a record. So you see the set nomenclature here. Character is the smallest element. A group of characters create a field. A group of fields create a record. Then a group of records together is called a file. And then a collection of files is called a database. So it's very much set theory. We start from the smallest character, then up to a field, then up to a record, then up to a file, and then up to a database. This is a representation of a human resource database. You'll notice that there's 2 files underneath the resource database called a payroll file and a benefit file. Below that, we see that there are 4 records. They're called Employee Record 1, Employee Record 2, Employee Record 3, and Employee Record 4. Within each one of the records, you'll notice that there's the same identical field names. There's name field, Social Security number field, and salary field. If you had to identify what is the unique field within each one of those records, you could easily identify that the Social Security number field is the most unique field within that record, which is in with that file within that database. You could say that name field could be also unique, but what is the likelihood that you will have 2 Tom Jones and Steve Smiths? There's a possibility that you could have duplicate names. However, Social Security number is unique identifier for each one of the fields and records. Because of that, we call that a primary index field. There are multiple types of database structures. One of the first database structure is called the hierarchical structure. This is a tree-like structure of one-to-many parent-child relationships where each child can only have one parent. This is one of the very first database structures developed, and it's not used very much today. The second type of database structure is the network structure. It's similar to the hierarchical, but allows for many-to-many relationships, or a child record to have more than one parent. This was more powerful and is still used in some rudimentary programs where simplicity and speed is required. Then we have the relational structure, which is the most widely used database model today. It does, however, have a lot of overhead. It is slower than the network or hierarchical structures. So when we have vast amounts of data that we want to relate and associate the data with each other, we use the relational structure. The relational structure is a series of two-dimensional tables or multi-dimensional tables called relations. Each column is a named attribute of the entity, and each row is an unnamed instance of the entity. The relational structure is very powerful because of some operations and commands that can be formed. The first command is called the select statement. It allows us to create a subset that meets specific criteria. This is very important because relational database structures can be huge. So sometimes we don't want to process through all of the database. We only need a subset of that database to be processed. The select statement allows us to do that. Then the join command allows us to combine two or more tables together in a temporary basis so that we can perform specific operations like displaying information on the screen or printing a report. Then we have the third operation, which is called the project, which is creating a subset of the columns in temporary tables so that we can perform mathematical operations faster, and we can also produce reports and display information on the screen more effectively. Then the last structure is called a multidimensional structure. It's a variation of the relational model, but it uses multidimensional structures to organize and express relationships. It's fairly complicated and requires special techniques and tools. Here are examples of what the three structures look like: hierarchical structure, the network structure, and the relational structure. You see that diagrammatically they look quite different from each other. This diagram identifies the relationship between department number between two different tables in a relational database structure. The department number then becomes the key, or the primary key that allows us to join those two tables together to obtain the correct information. And this is a diagram of multidimensional tables. You'll notice that they're presented in a cube, which helps us identify the multidimensional nature of them. These multidimensional tables are extremely useful for things like, well, in the aerospace industry it was missile trajectory information, but also used in weather forecasting today. There's also an object-oriented structure, which is used a lot for web page development. It combines the data of interest and processes that act on data into a structure called an object. The object then has several characteristics to it. One is called encapsulation, which allows complex data types to be performed within an object. The second is called inheritance, which allows replication of some or all of the characteristics of a parent object into the creation of a child object. This is very powerful for database programmers who are displaying the information on web pages. And of course, with all these different types of databases structures, we have to have an evaluation process, because as the databases have grown more complex and our data needs have increased so rapidly, it's very important that we identify the correct database for the business need. This is a representation of an object-oriented database that the parent object is called the bank account object. A checking account object has some of the attributes that are inherited from the parent bank account object, just as the savings account object has different attributes than the checking, but that are common to the parent or the bank account object. This is a good representation of object-oriented database. Database structures are so specific that we must have specific people that help us identify, work with them. So we have a position called a database administrator, and they help design, develop, and control and administer the databases. They also perform a process called tuning databases. Databases become so large and unwieldy and so a huge amount of data that you need someone that's going to be able to trim them and make sure that they operate at peak efficiency for the type of database structure that's in use. To help us understand the data that is within the databases, we have a database data definition language, or a DDL. This identifies the contents within the database and identifies the relationships and the structure of the database itself. This document, or this book in the DDL, is extremely information. The DDL usually resides within the data dictionary, and this is sometimes a physical binder or physical book that contains all the metadata or data about the data. Metadata means data about the data. And here's exactly what I said. Metadata is data about the data. And there is a specific planning and design process for databases. We call it data modeling, and one of the most popular diagramming tools that we use for data modeling is called the entity relationship diagram. It allows us to logically model the data and identify the relationship between the data before we actually start building the data. Then there's two other diagrams or definition processes that are very helpful too. One is called the schema, which is a physical internal view of a system, and the subschema, which is the logical external view of the system, or what users might possibly see. There is a process for database development which is very similar to software development. We start off with data planning, which develops a model of the business processes to help us understand which data is needed. Then we go through requirement specification, where we define the information needs of the end users. Now we've just transitioned from data into information in the requirements specification. Then we perform a process called conceptual design, which expresses all of the information requirements in the form of a high-level model, and many times this is done with the entity relationship diagrams for data modeling. Then we move into the logical design, where we translate the conceptual models into the data model of the database management system that we have selected. Then we go into physical design, where we determine the data storage structures and access methods, how we get to get the data in, and how are we going to get the data out. This is an entity relationship diagram, and it represents, starting on the left, we have a purchase order, and a purchase order contains multiple purchase order items. Those items, purchase order items, are then related to products. The products then are identified. Are they in stock? The product stock, where are they? Who has them? And then also supplies of who is supplying the product. And then of course down at the bottom we have the holds, which are what warehouse has the product stock. This relationship diagram is very helpful for database managers to understand how the data relates to one another. This diagram is then also provided to the programmers who are going to write software that will allow them to access those tools and some of those commands that we talked about earlier, the select, join, and project, and allow them to write software around it so they can access information from the database easily.